Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about a large sample test for single mean, test for difference of mean, test for specified standard deviation, test for difference of standard deviations, and test for single proportion. Also, test for difference of proportions have been done. In continuance with the large sample test for difference of proportion, we will work out some more problems in large sample test for difference of proportions and interval estimation. And after the large sample test discussion is over, then we will step into discussing small sample test. With the first test, students t-test will be discussed in this session. After working out 13 examples in the test of significance, the 14th example now is in a large city A, 20% of a random sample of 900 school children had defective eyesight. In other large city B, 15% of random sample of 1600 children had the same defect. Is this difference between the two proportions significant? Obtain 95% confidence limits for the difference in population proportions. There are two types of samples being taken. One sample taken from a city A of among the school children having the defective eyesight, and another sample is taken from the city B, again the children having the same defect. So, what are the values? We will have to just enumerate it here. First of all, sample 1, or it is taken from city A, and sample 2 taken from city B. N1 is equal to 900 and 20% of random sample of 900 school children. Therefore, the sample proportion will be 20%, which is equal to 0.20. Similarly, N2 is equal to 1600 children, and P2 is equal to 15%. Okay, 15% in the sense 0.15. Converting it to decimal places for use in problems. Next, we will start up the procedure for testing of significance. Step 1 is set up the null hypothesis as capital P1 is equal to capital P2. That is, there is no difference between city A and city B as regards the children with eye defect is concerned. So, we set up H0 as P1 is equal to P2, and the difference between two proportions in the sense population proportion of city A and population proportion of city B with respect to school children having the eye defect. Two proportions is not significant. Then step 2, H1 will be P1 not equal to P2. So, the difference between two proportions is significant. Then level of significance will be is given to be equal to, we have to take a 5% because next subdivision you have to find out the 95% confidence limits. Okay. So, step 4 we go ahead with the calculations. Z is equal to P1 minus P2. This is the formula we studied, root of PQ into 1 by N1 plus 1 by N2. Now, here the population proportion value capital P and capital Q is not at all given. Therefore, we have to take the estimates of P and Q as capital P cap and capital q cap. So, in the place of capital Q and capital P not available, therefore, we have to take its estimates where capital P cap is equal to P is N1 P1 plus N2 P2 divided by N1 plus N2, and N1 is 900 into 0.20 plus 1600 into 0.15 by 900 plus 1600, which is equal to 0.168. This is P value, and Q is equal to 1 minus P is 1 minus 0.168, which is 0.832 Q value. Okay. And now therefore, we go ahead with calculating Z value. Z is P1 minus P2 divided by root of PQ. PQ is 0.168 into 0.832 into 1 by N1 plus 1 by N2. 1 by N1 is 900 plus 1 by 100. Before that, I will substitute the values directly. 0.20 minus 0.15. After calculation, the value comes to be equal to 3.21. Okay, the whole value. So, calculated Z at 5% is 3.21 and tabulated Z at 5% is 1.96. Since the calculated value being 3.21 is greater than 1.96, H naught is rejected. So, the ultimate answer for the question asked is the difference between two proportions significant? No, the answer to the ultimate question asked in the given problem is H naught is rejected. It means the difference between H naught is rejected means H1 is accepted. So, a difference between two proportions is significant. Okay. Now therefore, we have answered to the one part of this question. Now another part of the question is you have to obtain 95% confidence limits. Okay. What is that 95% confidence limits for the population proportion? It is P1 minus P2 plus or minus Z at 5% into standard error of P1 minus P2. Okay. Standard error of P1 minus P2 is Z at 5% is 1.96 and standard error of P1 minus P2 for this problem is root of PQ by 1 by N1 plus 1 by N2, or instead of finding the P and Q values, this also can be written as P1 minus P2 plus or minus 1.96 into square root of P1 Q1 by N1 plus P2 Q2 by N2. Since for the estimates capital P cap small p has to be used only for testing the significance, because we are concerned whether the value is greater or lesser, the value only is important, whereas here in 95% confidence limits you are exactly finding the value, whereas in testing the significance you are just finding the value and comparing it with the tabulated value, so that a point differences is acceptable, that is when it is greater it H naught is accepted. So, that kind of difference is accepted in testing the significance, whereas in finding the confidence limits you must be very careful, because you are going to write down the exact values. Therefore, estimates cannot be used, that is P cap and Q cap cannot be used. Therefore, instead of that formula we are writing P1 Q1 by N1 plus P2 Q2 by N2. Now, substituting all the values, P1 is 0.20 minus 0.15 plus or minus 1.96 into square root of 0.2 into Q1 will be 0.8 by N1 is 900, and P2 is 0.15 into 0.85, Q2 will be 0.85 by 1600. Okay, and this value happens to be equal to 0.05 plus or minus 0.031. So, one value with plus and one value with a negative sign gives you 0.019 and 0.081. These are the 95% confidence limits. For the difference of proportion. Now, continuing with the difference of proportions, one more problem is worked out because there are various formulas in difference of proportions. One is using the estimate of the population proportion, another one is directly using the population proportion, and another one is without using the estimates, direct only sample proportion values. Now, let us see how this example is different from the previous ones. On the basis of the total scores, 200 candidates of a civil service examination are divided into two groups, the upper 30% and the remaining 70%. That is, the top ranking 30 people out of 100 has been ranked as upper group and the remaining as 70%. Consider the first question of this examination. Among this first group, 40 had the correct answers, whereas among the second group, 80 had the correct answer. On the basis of these results, can one conclude that the first question is no good at discriminating ability of the type being examined? Okay. Let us see how this problem goes. Here the proportion values is not given, whereas you are given the total sample size and the number of successes, right. Therefore, we have to take x1, n1, x2, n2, etc. From x1, x2, n1, n2, we have to find out p1 and p2. So, first of all, write down the values given in the question. Sample 1 is the first 30% of the people, upper group, and sample 2 is 70%, which is the remaining people. Okay. In this, n1 is equal to 30% of the total. Total people is equal to 200. So, 30% of the total is 30 by 100 into 200 is equal to 60, and similarly n2 is 70% of the remaining, right. So, 70 by 100 into 200 is equal to 140. So, n1 is 60 and n2 is 140, then x1 represents number of candidates with correct answer, number of candidates with correct answer in first group, that is equal to 40. Similarly, x2 will be the same thing, but in second group. Okay, and they are 80 in number. So, what is the sample proportion? P1 is equal to x1 by n1, x1 is 40 and n1 is 60, and P2 is equal to x2 by n2 is equal to 80 by 140. Then automatically Q values will be there. Next we will go ahead with testing the difference of proportions. So, step 1 goes like set up null hypothesis H naught, capital P1 is equal to capital P2. That is, there is no difference in the population proportions between the first group and second group. That is, in other words, we may say that the first question is not good at discriminating the ability of the type examined. Okay. So, H1 will be P1 is not equal to P2. So, you just have to repeat. First question is at discriminating. Discriminating the ability of the type. Okay. Then step 3 is fixing up level of significance. Level of significance fixed is 5%, and next step 4 is calculation part. Z is equal to P1 minus P2 divided by root of PQ into 1 by N1 plus 1 by N2. Since P and Q is not directly available, we have to take its cap values. Cap values is small p, where capital P cap is equal to small p z, which is equal to x1 by n1 plus x2 by n2. This is with respect to the number of successes out of a number, total number of the sample. So, 40 by 60 plus 80 by 140, okay, and this value happens to be equal to 0.6. All these stands for proportions. Therefore, proportionate addition has to be done, in the sense 40 plus 80 divided by 60 plus 140. This kind of addition should not be done in other cases. This is addition called proportionate addition. Therefore, it becomes 120 by 200, which is equal to 0.6. So, capital Q cap is 1 minus capital P cap is equal to 0.4. So, substitute all the values the Z formula. Z is equal to P1 minus P2. What is a P1? 0.667 minus 0.5714 by root of 0.6 into 0.4 into 1 by what is N1 60, N2 is 1 by 140. Now, in this problem actually we have calculated N1 and N2 also from the percentage, from the proportion, okay, and this answer comes to be 0.0953 divided by 0.0756, and the answer is 1.258. Calculated Z at 5% is equal to 1.258. Next we will go ahead with the tabulated Z and the conclusion step. So, calculated Z at 5% is 1.258. So, tabulated Z at 5% will be 1.96. When just compare, 1.258 is lesser value. Therefore, calculated Z at 5% is less than tabulated Z at 5%. Hence, H naught is accepted. When H naught is accepted, what is the H naught statement? That should be written as a conclusion. That is, the first question is not at discriminating the ability of the type. That is, the two population proportions are equal in the sense of answering the first question. The first question is not good in discriminating the ability of the type. We have answered to the question given, that is, the first question is not good. You have been asked to verify whether the first question is not good. Yes, the first question is not good, that is the answer. Okay, next, here the sample values are not at all given, sample proportion values are not given, and you are given only the population values. Let us see how the problem is worked out. In two large populations, there are 30% and 25% respectively of blue eyed people. Is this difference likely to be hidden in samples of 1200 and 900 respectively from the two populations? Therefore, here only the sample size is given, whereas sample proportion is not given, we are given only the population proportion values. It is actually well good when population values are directly given. Why we are taking the sample? The sample is taken because a complete enumeration of the population is not possible. When the population values are available, it is given first preference for calculation. We are given capital P1 is equal to 30%, which is 0.30, and capital P2 is equal to 25%, which is equal to 0.25. N1 is equal to 1200, N2 is equal to 900. Okay. Now, with these values you have to calculate the Z value. So, first of all we will step into finding setting up H naught. H naught is that capital P1 is equal to capital P2. So far we have been set. Now, since capital P1 and P2 values are given, we say that small p1 is equal to small p2. Slightly difference in null hypothesis so far set, that is population proportion always will be taken as equal in null hypothesis. Since population proportions are given and you are asked to test whether the sample proportions also differ similar to population proportions, therefore we have to take the sample content for the null hypothesis. So, that is sample proportions are equal. It means the difference in population parameters is likely to be hidden in sampling. Now, set up H1. H1 is small p1 is not equal to small p2. That is, the sample proportions are not equal, or the difference in population parameter is not likely to be hidden in sampling. Okay. Step 3 is level of significance 5%. Step 4 is the usual formula. You just write the usual formula, then we will convert. Z is equal to small p1 minus p2 divided by root of pq into 1 by n1 plus 1 by n2. Since the values are directly available for the population, small p1 now will become capital P1 minus capital P2 divided by, and since P1 is equal to P2 is equal to P is not suitable here, therefore we have to write the formula as P1 Q1 by N1 plus P2 Q2 by N2, because capital P1 is not equal to capital P2. Capital P1 value you are having 30.30 and capital P2 is 0.25. Therefore, it cannot be taken as it is. So, 0.30 minus 0.25 divided by root of 0.3 into Q1 is 0.7 divided by what is N1? N1 is 1200 plus 0.25 into 0.75 by N2 is 900, and this is equal to 0.05 by 0.0195, which is equal to 2.56. So, calculated Z at 5%, we will come to conclusion step, is equal to 2.56, and tabulated Z at 5% is 1.96. Therefore, calculated Z is greater than tabulated Z here, greater than tabulated Z at 5%. Therefore, H naught is rejected. H naught is rejected in the sense the difference is not likely to be hidden. What is your H1 statement? H1 statement only is our conclusion now. because H naught is rejected in the sense H1 is accepted. The difference is not likely to be hidden in sampling. Now, large sample test is discussed with the test of a single mean, test of difference of means, test for difference of means, test for specified standard deviation, and test for equality of standard deviations, and test for single proportion and test for difference of proportions. After discussing all these things, next we will step into discussing small sample test of significance based on t distribution. Now, when the sample size n is less than or equal to 30, then the sample will be called as a small sample, and there are various tests of significance based on a small sample, that is t, f and chi-square in a small sample theory. First of all, a student's t distribution will be discussed. Let me explain what is the use of student's t distribution. The student's t test is used to test the mean, whether it is single mean or difference of means or paired observations, but student's t test is used for testing the mean in small sample theory. In this session, large sample test for difference of proportions have been discussed in various angles, in the sense when the population proportions are only given and sample proportions are only given, and then when the population proportion value is not directly given but only its estimate can be used, and also interval estimation for the population proportion is also done. And then after discussing the large sample test, we started discussing the small sample theory along with the student's t test. Based on this discussion in this session, the following questions may be posed. In a year, there are 956 births in a town A, of which 52.5% were males, while in towns A and B combined this proportion is a total of 1406 births, was 0.496. Is there any significant difference in the proportion of male births in two towns? Okay. And this is the problem in difference of proportions. Next question is, in a random sample of 400 students of the university teaching departments, it was found that 300 students failed in the examination. Now, this is a particular problem where the sample size is given and the number of successes is given, that is capital X1 and N1 is given. You have to accordingly find out the calculated value and draw the inference using one of the problem worked out in this session. In another random sample of 500 students of the affiliated colleges, the number of failures in the same examination were found to be 300. Find out whether the proportion of failures in the university teaching departments is significantly greater than the proportion of failures in the affiliated colleges taken together. Thank you.